Chapter 8 starts off talking about something called variation. Variation is really just the way that something changes. So we start with this idea about the depth that a scuba diver is in the water and the amount of pressure that's exerted based on that depth. And you can actually calculate this pressure, which is in kilopascals per meter. So what you do is you just take one divided by the other and you end up with this same value. So this is actually a ratio, and that's really what variation it starts to become, is a ratio. This kind of ratio is actually called direct variation, and it's something you're all very familiar with because essentially it's in the shape of a line. As long as the slope of the line is not equal to 0, what we say is that y varies directly as x, meaning it is direct variation. The constant is actually the constant of variation. We also call that a slope. So this graph of direct variation is a line through the origin with whatever the given slope is, m. So here we have x1, y1, and x2, y2 as ordered pairs on the variation. And neither one of those is 0. Then you can find the slope by taking the ratio. So therefore, any y over x is equal to any other y over x. And anytime you have two ratios that are equal to each other, we call that a proportion. Here I'm going to use some different terms to describe the same thing. So in a direct variation, we say that y is directly proportional to x, and m is the constant of proportionality, right? We just said it was the constant of variation. That's the same. And you actually can write it like this. When you do this, we actually have terms for each one of these. So these two inside values here are the means, and the two outside values are the extremes. What we can then do, right, so we can look at it like these two ratios, or we can write it as a proportion. And we're familiar with least common multiples with denominators. And if you look at the least common multiple of these denominators, it's x1, x2. So if you multiply each one of those fractions by the common denominator, what happens? That cancels, you get y1, x2 is equal to x1, y2. So what that means is that the product of the means, right, the product of these two numbers, is equal to the product of the extremes. So now we'll do a couple of examples. If y varies directly as x, and y equals 25 when x is 15, find x when y is 40. So the first thing we'll do, right, we've got a direct variation, which is in the form of y is equal to mx. Then we're told that y is 25 when x is 15. So what we'll need to do is we'll need to solve for m. We all know how to do that. We divide by 15 on both sides. This cancels, this gives me 5/3. So m is equal to 5/3. So now it says, well, let's find x if y is 40. Okay, so I've got 40 is equal to 5/3 times m. Again, we know how to do this. We multiply by 3/5 on both sides. That cancels, makes this 8. And I think I wrote this wrong. This should not be an m. This should be an x. There we go. So x is equal to 24. Let's look at another one. If a is directly proportional to b cubed, and a is 10 when b is equal to 2, find a when b is equal to 4. So here, if I'm thinking about it being directly proportional, now I'm thinking about that proportion or the equality of ratios. So I can set this up as A1 over B1 is equal to A2 over B2. Well, A1 is 10, so that's 10 over, and it says B is 2, so we have to cube that, right? So let me write that this is cubed, and that is cubed as well. So 10 over 2 cubed is equal to A over 4 cubed. Again, this is pretty simple. 2 cubed is 8, so I have 10 over 8 is equal to A sub 2 over 64. And then using that idea of means extremes or clearing my denominators, however you want to think about it, you would multiply by 64 on both sides. That would leave you with A sub 2 on the right. This cancels, that becomes an 8. And I don't know why all of that just moved, but the answer is now 80 is equal to A sub 2. So now we'll look at this word problem. The amount of hydrogen produced when sodium is added to water varies directly as the amount of sodium added. So first thing we need to do is write out this equation. So I'm going to say the amount of hydrogen is H. And it says that it varies directly as the amount of sodium added. Knowing it varies directly, I have to give it some constant, and now I've got the amount of sodium added. If 92 grams of sodium produces 4 grams of hydrogen, all right, so 4 grams of hydrogen, 92 grams of sodium times the constant, we need to find the amount of sodium needed to produce 10 grams of hydrogen. So let's solve for K first. We divide by 92 on both sides and get that K is equal to, that would not be right, 4 over 92. Which of course we simplify to 1/23. So now I need to find the amount of sodium needed to produce 10 grams of hydrogen. Well, hydrogen is 10, K is 1/23. And then I've got S. So the simple thing here, we multiply by 23 on both sides. This cancels. 230 equals S, so we could write out our sentence. 230 grams of sodium is needed to produce, we'll just say to make 4 grams of hydrogen. (8.2) is still dealing with variation, but this time we're looking at inverse variation and joint variation. And the way that that we model this is with our favorite thing, distance is equal to rate times time. We know that if our distance is held constant and our rate is increased, our time decreases. The example, the greater the average speed of a sprinter, the less time it takes for him to run 100 meters. Right, so in this case, that 100 meters is our distance. And we've got a rate and a time. Well, if I want to know what the time is, I simply divide by the rate. And one thing about this particular function is that this time will never actually be 0. Even if you move at light speed, there is some amount of time, even if it's slightly minute. So it will never actually be 0. So we say that time varies inversely as the speed, which is what I've got here. So here, we've still got x, y, and k, but this time x and y multiply together to get us this constant, or if we're looking at it like a function, y is equal to the constant divided by x, meaning that x is in your denominator, and this is called inverse variation. And we say that y varies inversely as x, or that y is inversely proportional to x. That constant k is the constant of variation, or the constant of proportionality. We can also do a kind of a combination which is called joint variation. So when we've got something that varies directly as the product of two or more, meaning you're multiplying two or more things, we call that joint variation. Taking a look here, it says that z varies jointly as x and the square of y. The square of y in this textbook means y squared. And we've got this constant that has to be multiplied, so this would be any non-zero constant. And we can say that z is jointly proportional to x and y squared. So it's probably easier to show than to try to describe. So it says y varies inversely as q. Okay, the first thing I'm going to think of is y is equal to k over q. Okay, y is 22 when q is 6. So I have to solve for k. 22 times 6, that's 132. So now find q when y is 15. Well, here we'll need to multiply both sides by q, and then we'll need to divide by 15. So that q is equal to 132 over 15. Plugging that into your calculator, you get 44/5, or you can say that it's 8.8. The next problem, if r varies jointly as s and t and inversely as u. So that's kind of the first thing that we need to set up. How do we write this? R varies jointly as s and t and inversely as u. So right, so there's your jointly as s and t and inversely as u. Now we know that r is equal to, this is actually positive 18, please change that in your notes, when s is 2, t is 3, and u is 4. So what we'll have to do is we'll have to plug all of these in to find k. So that's 18 is equal to k times 2 times 3 divided by 4. So when I'm solving for k, alright, so the first thing I'm going to do is cancel out this 2, make that 4 a 2. Then I'll multiply by 2/3 on each side. That cancels, the 3 cancels here, gives me a 6 here, and k is equal to 12. Now I have to find s when I'm given some other values. So r is 6, k is 12, s is what I'm looking for, t is 2, and u is 4. Again, I will simplify this as best I can. This becomes a 3. So 3 times 2 is 6, and s is equal to 1. Now we'll look at some word problems that involve inverse and joint variation. So the time required to travel a given distance is inversely proportional to the speed of travel. So again, I need to think about this. Time is inversely proportional, there's my constant, to the speed of travel. A trip can be made in 3.6 hours at a speed of 70. So 3.6 is equal to my constant over 70. So in order to solve for k, I multiply by 70 on both sides. Once I've done that, I find that K is 252. Now, I have to figure out how long it will take to make the same trip at 90 kilometers per hour. How long will it take? That means I'm looking for time is equal to 252 over 90. Well, that's simple enough to put right into your calculator, and that time is 2.8. So you can say it will take 2.8 hours. The last one, it says, for cones of equal volume, the height is inversely proportional to the square of the radius of the base. So the height is inversely proportional to the square of the radius of the base. If the radius of a cone is 10 centimeters and its height is 15, stop right there. They're giving you the information you need. Height is 15, the radius is 10. So you multiply both sides by 100, and you get that K is 1500. Find the radius of a second cone of equal volume with a height of 60. So here, height is 60, K is 1500, and then I've got R squared. So I need to multiply by R squared on both sides, and then I have to divide by 60 on both sides. Now 1500 over 60 is 25. We take the square root of both sides. Now I hope that you're noticing, oh, she's got to do plus or minus because she took the square root of both sides. You have to say plus or minus, and you are correct, except a radius cannot be negative, so here only the positive value is the one that's valid. So we can say the radius of the second cone is 5 centimeters.